Hey guys, so here's the notes for 2.7 extension day 2. We're going to be talking about how to graph a piecewise function. So let's talk about what is a piecewise function. Well, basically it's defined by at least two equations, and for this purpose we're only dealing with linear equations, each of which applies to a different part of the function's domain. Now, when you do piecewise functions, you really can do a lot of different stuff. We could be dealing with like quadratics, exponentials, absolute functions, but since we've just been dealing with a lot of linear equations, that's what we're going to be dealing, okay? And so when it says applies to a different part of the function's domain, that just represents, as you saw earlier in our 2.7 extension day 1, there's going to be a restriction. So basically that 2.7 extension day 1 notes, that was basically a preview of what we're going to be doing for our extension day 2 and extension day 3 notes dealing with piecewise functions. So notice the form of a piecewise function. So we're going to have like y equals or f of x equals g of x. It doesn't matter. You're going to have something that looks like that. Equals. Then you're going to have a curly bracket. Within that curly bracket, you will have the equations. And then for each equation, it will have a restriction. Okay. Now, before we get into actually graphing piecewise functions, the first thing we're going to do is evaluate piecewise functions, okay? So when we evaluate, we're going to have to look at what is the number inside our x value and determine, okay, which one does it work for? Are we going to plug it into the first equation or the second? So you only get one solution. You don't get multiple, just one. So let's look at our first one. We have g of 1. So we need to decide where we're going to plug the number 1. Are we going to plug it into our first equation or second? Now, to know which one, or to decide which one to plug it in, basically this number 1 has to satisfy one of the restrictions, okay? So if I plug 1 into my first restriction, is 1 less than or equal to 1? Is that a true or false statement? It is true because 1 is less than or equal to 1. So because it satisfies the first restriction, we're going to plug the number 1 into our first equation. So we're going to have 2 times 1 minus 1. And so that means we'll get 2 minus 1. That gives us 1. So our answer is just 1. Okay? Okay, let's try the next one. We have g of 5. So we either will plug that into our first or second equation, but we have to see which one does it satisfy. Well, let's try the first restriction. Is 5 less than or equal to 1? No, that's false. Okay, let's try the second one. Is 5 greater than 1? Yes. So since the 5 satisfies the second restriction, we're going to plug the 5 into our second equation. So we do 3 times 5, that gives us 15 plus 1, so that is 16. 16 is our answer. Okay, go ahead. I would like you guys to pause the video and try number 3 and number 4. Okay, let's see what you got. So 0. So let's see. For our first restriction, is 0 less than or equal to 1? Yes. So we're going to go ahead and plug 0 into our first equation. So we get negative 1 as our answer. Okay, what about negative 2? Is negative 2 less than or equal to 1? Yes. So we also plug negative 2 into our first equation. And so when we do that, we get negative 5 as our answer. Okay? Okay, so that's how you evaluate. Make sure you watch the next video. We're actually going to be talking about how do we graph piecewise function.